Hope you had fun. I'm indeed my name. The only thing I understood just now that was my name. So that's Bob van Luit. That is correct. I'm from the Netherlands. I'm from Amsterdam, and so I traveled here last evening. And I'm going to talk to you about something which I like to call the Semantic Internet of Things. And I want to talk to you about why I think that's important. I want to talk to you about why I think it's important that you think about the things that I'm going to talk about. Or maybe disagree about the things that I'm going to talk about. All is fine. So the first thing actually that I want to show is it's just on a side note, but it's just because it's great that for this whole, these GDG events, I get to travel like everywhere. So I put up this little website where I'm traveling, and the reason because I thought now I can quickly promote something which I didn't not have in my slides, and I built this thing actually with Cloud Functions, which is great. So if you have not tried that, you should try it out because it's a lot of fun. But that's not what my talk is about. So my talk is about something that's on my blog. So I promote my blog here. Go to my website, right? So my website is bob.wtf. If you wonder what that means, yes, that stands for what the fuck. That's correct. I thought somebody invented to make that top-level domain. I don't know who that is, but he or she is amazing. So I thought and they didn't have Bob, so I thought bob.wtf, so that's my website. And there's an article there on which I call the Semantic Internet of Things. And semantics in IoT is not really new, but I hope to spin that a little different and hope to spark your imagination about what I'm doing with that. So, and basically it starts here. So these are comic books. I like to read comic books. These are American comic books. I also like Japanese comic books a lot. But there's something special that you can see in comics. And that is actually something which they call breaking the fourth wall. And I don't know if you ever heard of that principle, breaking the fourth wall. But that means that you can see with Deadpool here. So he talks about something and then he tells the reader, if you don't have it, play whatever the crap you like. So what he's doing, he's talking to you, to the reader. He's going through the fourth wall. So there's this different world in the comic book. And now he comes out of the comic book and he talks to you, the reader. And now you think, so why is that interesting? What's so important about that? Well, I think we're really close by that that's going to happen to us too. So I think soon this, for example, this droid, right, will go out of the fourth wall. So we slowly start to see signs how things in our machines are coming out. They're breaking the fourth wall. Exactly the same way like Deadpool is doing. Because traditionally we know, right, so we have everything that's digital, right? It's stored in bits and bytes. And those are the things that we see mostly, right? So we create apps, we create websites, we create services, we create, IoT devices, right? That's basically this. They live in bits and they live in bytes. But slowly we start to see that people are also manipulating that. So you get these kinds of things, right? The whole AR stuff. You see what I mean? So this is slowly, it's starting to get out of the screen, slowly. It's not there yet, but it's slowly starting to get in our imagination, like how can we escape the screen? So the question is how do we do that with this, right? So how do we get this into the, how do we manipulate that through software or through hardware, but probably through software? How do we do that, right? That's the question. That's the question that I'm trying to answer. So there are basically these three sections, right? So the digital world, that is where, I guess most of you in here, that's where you work, right? So that's what I mentioned in the webs and the app, the websites, apps, and what have you. Some of you might be doing augmented stuff, but you might even be thinking about that from the digital perspective. But I'm much more interested in the physical world, because that's where we live in. We don't live in our apps. We live in the physical world, right? I find that much more interesting. That is why I like IoT so much. It is something about what we do, about us, how we interact with each other. And there's this saying, right? So there's saying if you express something in bits and bytes, the world works different than if you express something in atoms. So the world works different in bits and bytes than if you express them, or the things like they are in atoms. I'm going to give you a very simple example of this. This is much simpler than it might sound. And there's actually, do people know who this is? No, no, no. Okay. This guy, well, his name is below the circle. His name is Peter Thiel. And he founded, together with Elon Musk, PayPal. And then he was like a very early on investor in Facebook. So besides the fact that this man has like shitload of money, he also is very smart. So he wrote a book, 0 to 1. If you're interested in understanding what technology and all what you're working on has done for business, read this book. But that's not what I want to share. Actually, he said something very interesting. He said this. He says, like 40 years ago, we were dreaming about flying cars. And the only thing we got was 140 characters. We just learned that he's wrong. We actually get 280 characters, but still, I mean, that's quite a difference, right? So all those things we're doing, all the creativity that's going in there, all the people learning and studying for that, all the money that goes into that. And in the end, we're still left with 280 characters and no flying cars yet. And I agree with him, right? So the question is like, how do we get there, right? So how do we get to flying cars, and how we use the tools and the creativity around us to get there? So here we see like the world of atoms, and it's easy for you to imagine a car, right? Think of any car you want to think about, a car. What you can do, you can create a digital twin of this car. That's a term, digital twin. In a digital twin, it is believed that you can represent everything that's happening in the physical world in the digital world. I believe so too. And what you can do with that is you can manipulate the car. I mean, it's not hard to imagine to have a digital car and change that into a flying car, right? The magic that you have to do there is not very much, especially if you write software. Just imagine you just have a car, and then you make that car the digital twin, which is digital, and maybe you see that, visualize it in an app or on a website or in a game, whatever. Making it fly is not that hard. What is hard though? How do we get it out? We somehow need to get there. We need to somehow get that out. And now you might be thinking, well, Bob, you're crazy, or maybe last night you have been drinking too much vodka or whatever. No, 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 no. I'm serious. So yesterday, or the day before, I saw that, for example, Elon Musk, he presented what he's doing with his rockets, right? So he's carrying spaceships that allow you to travel around the world in 30 days. And he says we will do that in like 30 years or something. In 30 minutes. You can go from one side of the earth to the other side. And in 40 years he wants to build moon bases where we go, etc. They're actually doing that. And now this is a leap of things. So this is like a leap of the imagination. What I'm saying is I believe that they're able to do that because they understand what's underneath there so well. The people work on that in, for example, SpaceX. They understand so well how the digital works. And they are able to make that leap there. They are able to bring that back in the physical world. And I know that might sound like a difficult concept, but that's the whole thing that I'm going to argue. So I'm going to argue we need to think about how do we, what we learned in writing software and creating things digitally, how do we bring that back out into the physical world? How do we break that fourth wall of our screens? So this thing is interesting, having the magic wand to do that. And this is also interesting, right? Bringing it out again. And so the question about like the wand and like who can do that, who has this power, who has this magic to actually do that, right? Who has the wand, the power to actually make that change and change that digital car into a flying car? Well, that answer is very simple. You, right? You write software, you design, you might have technology businesses, you think about that. So you are the people making that. Think about that. So what's even more interesting, that is the question, oh yeah, all those tools that you have available, right? Holy shit, look at this. This is insane if we just pick one of them, right? So if you look at search, for example, just only search. Holy cow, it's amazing what that's done for us, right? So what it brings, and you use all those tools and you make those new things, but you haven't built a flying car yet. But you're close, because the first step you already solved, all of you, you know the magic. You know how to do that, how to change that information into a digital equivalent of the flying car. but you haven't brought it out yet. And this is the tricky thing, of course. And this is why I'm so interested in IoT. Because IoT brings us a little bit closer of getting out there. Now I don't have like a picture of pointing at you, because maybe you have one in your garage, but I don't think so. Nobody has brought the car out yet, right? Or an equivalent, such an exciting thing. So the question is, what I'm going to talk about is like, how do we get there? And I mean, I'm talking to you, right? So I also should look in the mirror and talk to myself. So how to get there? How do we get there? So let's first look at what those things have in common. So what's the denominator of those things? All those ideas that we have, what do they have in common? Us, humans. Humans observe these things. Humans think about these things. There are no aliens involved, no monkeys involved. Humans. Humans do that. Humans think about that. And humans communicate and humans observe things and think about things with the 5 senses that we have, right? So everything that we come up with, everything that we do, we taste, we hear, we touch. Obviously we see, especially when it comes to devices, right? Or we smell them. It's not more than that. It's that combination of 5 things that we have, which we use to make those new steps. And that information is transacted to our brain. So everything that we think about, everything we observe, somehow goes to our brain. Example. Think of your favorite user interface. Just user interface, think of one. Everybody has a user interface. Your favorite user interface. Everybody has one? So my favorite user interface is this, the chair. I think it's an amazing user interface. It's so clear. When I see it, I know exactly what it wants me to do. And there are even people who make like great UXs on user interface, because you can sit in them and they're nice to sit in, but it's a great user interface. It's much clearer than most apps that I use. I don't understand how they work. They're vague. But a chair is very clear. There's nothing different between a chair and an app in a user interface. It just evolved over time and it's so clear to us, right? So what we do, we somehow observe the chair and we bring that to our brain. So right, so you can look at the chair and you see the properties that the chair has. So the class is the class chair and the properties that it has, like its legs, and you can sit against it. Maybe you can even you can smell the chair. Maybe it's made of leather, right? So something you can smell how the leather smells. If you squeak the chair or the wheels in the chair, you can hear how the chair works, and you can touch the chair, right? You can feel how the chair feels, and that combination, that somehow brings it to your brain. A few weeks ago, I was in Rostov, also here in Russia, and somebody raised his hand and says like, I don't agree with this. He said, because you forgot something. And the man insisted that I had tasting in there. So for this gentleman, by popular demand, he said, in theory, I can also taste the chair. Sure. So for him, tasting the chair. The point is, you use your senses to understand what the chair is. So I said, like, I will use one Russian word in my presentation, stool, right? So what we do with this, we write it down, right? So we write it down in the book or we write it down in an app. We communicate it to the brain, and then we know chair. And this is very interesting because the moment I say chair, all of you have a picture of a chair in your head. The cool thing though is, it's a different chair. We don't see the same chair. We know the properties of a chair and everybody sees a different chair. So how do we communicate that? Through language, right? So when I use the word stoel, in Dutch it happens to be also stoel, so that makes it easy. Or chair, or whatever, right? That's how we communicate. And we can write it down in the book, and then you can also read it. And everybody still knows it's about a chair, and we communicate it through language. You can put it in a computer, and then everybody still reads chair. Or you can put it in a computer, connect it to the World Wide Web. Everybody can read it, and we still talk about the same chair. So that's the great thing that Web 1.0 brought us, right? We had this communication from this person to the World Wide Web, and everybody over the whole world was able to read it. You didn't have to go to the library, you didn't have to order the book anymore, you could read it. And then the reason that we're able to sit in this room today is for a small change. And that's that. That arrow there. Because that arrow, that brought us Web 2.0. How is that so much different? Well, very simple actually, because this is a banking app, this is Airbnb. We made it interactive. We could ask questions to the digital book. Google search is a great example of that, right? You ask a question to the digital book. So now the question is, what is Web 3.0? What comes after that? What's the next big thing? Well, that is language communicated in the same way that a machine understands. You see? So this is again why I think IoT is so interesting. And in 2001 they introduced the semantic web. And the semantic web actually tries to do all the things that I just explained, but in a digital way. So if you read this sentence, Alice eats an apple while looking at an apple in the Big Apple, you know the context of this, right? You know that Alice is eating an apple. She's looking at an apple, which is the Dutch painter apple, this guy, while she's in New York, because the Big Apple is New York. If you show this to a machine in text and language, the machine basically does this. It does not understand you. And Web 3.0 tries to solve that for us. And this is how it looks. This is a schema.org example. They call that the ontology and how you write things. So here you see, can I actually use the, oh yeah, I can. So you see type person, Alice. She's a little girl. I made that up just to. And there's a product which is a red apple, which is manufactured by the apple picking business Incorporated. And she's doing that in the city of New York, which has an alternate name, basically the Big Apple, etc., etc., etc. So now you might go like, so what? This is all nice and fun, but what does this have to do with IoT, right? What's so interesting about this? Well, first time the term Internet of Things was introduced, that was by Kevin Ashton in 1999, and then he wrote like, and he basically makes the point. He says like the fact that I was probably the first person to say Internet of Things doesn't give me any rights to control how others use the phrase. It's interesting. But what I meant and still mean is this. Today's computers and therefore the internet are almost wholly dependent on human beings for information. Language. Conversation diagrams of the internet include servers and routers and so on, but they leave out the most numerous and important router of it all. People, us, humans, right? And that's a big deal. We are physical. It's the physical world. You remember what I showed you? Going with the car back to the physical? We're physical. And so is our environment, our economy, society, blah, 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 blah. So there are a few interesting things in there, right? So the term Internet of Things now became something. It became the smart fridge with a chip in it. Screw that. Forget about it. That's not what it's about. It's about human beings, people, who are physical and do something in the physical world. That is what IoT is about. And then he even closed off this here, you see, they're based on things. Because those classes, those devices, like the chair, a chair is a thing. You are a thing, your camera is a thing, the board is a thing, everybody's a thing. With the web semantics, we can express that about our physical world. So, you know, remember the robot? So now the robot can interact and understand actually what's happening in the world thanks to the web. So we express things that are happening in there through the web. And the robot can actually also have like not an actual brain, but like by matter of speech a brain, right? It can have senses. It can even have many, many more senses than we have. It can have radar. It can have infrared, what have you. We don't have that. I mean, I don't. Maybe you do. Right? So they can have many, many senses. They can learn much more about the world than we can. And if we ask them to explain that through web semantics in language, we can read it and we can understand the concept because it's about us, humans. So how do you do that, right? Well, there are great ways of mimicking senses. Let's look at the Google Cloud, right? The vision API, speech API, video intelligence, and there are more, more coming soon. Translation API to have different languages, right? But you even also have things like Android Things that help you to capture that information from the world. You can have a brain, right? Which functions in the cloud. You need to have power, brain quote unquote, brain power to process all that information. We could not do that 10 or 5 years ago, now we can. And you need to have brain storage. Tell you about what the W is later. This is a very simple example. This is something that I'm doing currently on a very, very large scale. So this is just a family. This is a combination of the Vision API, Android Things with a little camera on top of that. And I asked the thing to express me things about the physical world. It talks to me where things are in the world, what they do, how they interact, and where they are. Just a simple example. And I make them express that in semantics so that I can ask it questions. How many people are there in this room? How many dining tables are there in the room? Is there a sofa? You can ask it questions like you do to a human, and the machine can interpret it and answer you back. No fancy machine learning involved, just organization. Also, I'm a big fan of organizing your data, by the way. Always avoid the term data lake. You don't want a data lake. You want to have a tree, a knowledge tree, right? So you want to have your information organized. Web semantics helps you to do that. And then you get this beautiful graph that you see on the right. Still, I will get to you what the W means. So what you need to do, so first we know we have the magic, and the magic is nice because you all have the magic, right? We all have the magic. We know how to write the software, we know how to interact with that, because software, don't forget, software is not to instruct the machine how to do something. Software is for other humans to read what the program is doing. The machine is executing binary code, not your software. That's why you need to comment your software that others can read it and understand it. Software is for other humans to read. Another thing that not everybody of us has, but I hope you get it right. The unicorn, the idea, bring that out of the digital back into the physical, the flying car. And if you bring that all together, right, you get your flying car. So that's what you need to bridge. And we have all those tools available to help us do that. Bear in mind all those APIs that you're using, all those frameworks that you're using. Holy shit, if you do JavaScript, there's like every day there's a new framework. I mean, that's incredible, right? And what you then can do, you can come up with an idea. And then you have this, something like this, a Google Cloud Platform for startups, which I used. So it's like, I have an idea. Actually, this weird idea, what I just shared, I have an idea how to do that, how to write the software to get closer to that. So I told the people at the Google office in London, and I said, well, that's interesting, let's support you, I'll help you. So they made it possible for me to develop this on the Google Cloud Platform. And then I created this, Weaviate, which is on GitHub/Weaviate. And it's a semantic graph-based Internet of Things platform. You can let machines tell it, using web semantics, what's happening, what it's doing. And you can ask it questions using semantics. Everything you see in the world, you can express in this. Really everything in the world? Yes. Challenge me. Give you a bottle of wine, or whatever you want to have, if you can challenge me and you can put it in there. So, that's just one last question before we end, right? And that question before you go home, before you go to the after party, is the big question you need to ask yourself. You don't have to give me the answer, just answer it in your head. And that is, based on all this information, are you a wizard? Thank you.
Thank you. It was a great talk for me and really non-common for us, I believe.
I hope so.
Okay. If someone has questions, again, if you have problem with English, you can send me in Russia and I translate it. Okay? Questions? Okay, I have a question.
Oh, sure.
There are a lot of talks about artificial intelligence, and many believes that machine learning is our future. And again, things communicating with things, it's too sounds like artificial intelligence. And how can these things and things as Internet of Things and machine learning, how we communicate between each other?
This is a great question, actually. The question is like how you define AI. And it's a rhetorical question, so I'll answer it for you. Don't worry. No, but
I don't know.
yeah. So let me say how I define. I didn't make this up, by the way. There's like a great book, and I forgot the name. So if you want to know the book, just come after me after this talk. And it's taught in many universities actually when it comes to AI, and it actually says AI has 6 pillars. AI is not one thing. There's 6 things on which AI is built. And now I have to remember them from head, so I hope I'll do well. The first is knowledge representation. That is this. That's the representing the world in knowledge. The second thing is robotics or senses, ways to interact with the world. The third is language processing, because if you have language and we communicate in language, you somehow need to process the language before you can do something with it. The fourth is you want to learn something about possible future events, right? So if you go out and you, as a human, and you see a car driving and you're like, oh, I need to be careful, right? So you learn about future events. That's machine learning. Crap, 2 more to go. Then we have, we have reasoning. Reasoning, that is the thing that is not really solved right now. So reasoning is like, if you have that knowledge, that you understand that there's another context, right? So you reason with that information. And the 6th is...
we have to Google it?
we have to Google it. So I forgot the 6th. But the point to answer your question is like the... so what you actually can do if you... I can promote my website. If you go to my website, it's on my website.
Maybe?
Yeah.
Okay, let's try.
Yeah, but you, of course, yesterday evening when you were reading to my website, you saw that.
My history in browser.
Oh,
I believe I know.
Yeah. Yeah.
Okay.
Let me. Yeah, Bob. Oh, yeah. Here we go.
You're free.
Does this work? Yeah.
Oh, finally, no history. Great.
There you go.
You can answer. You can ask Bob why he called his site in that way.
Yeah. Oh, you mean? What do you mean with that way?
WTF. Okay.
Oh, you meant why I call it Bob.what the fuck? Yeah. Okay. Yeah. Because it's fun. Okay. So it's in here. So let me quickly look that up. It is. Here you go. So let's see what I forgot. So we have knowledge representation, computer senses, robotics, natural language reasoning, and machine learning. So which one I forgot? No, I said machine learning. Oh, well, I don't know which one I forgot. The point is, these are the 6, right? These 6 make... Okay, I might forgot. Whatever I forgot, doesn't matter. So the thing is, these are the 6, right? So this is called the complete Turing test. So Turing only had 4, and later they added 2 more, and that's what I do remember. So Alan Turing did not have robotics and did not have a senses. So senses is to learn something, and robotics is to interact with the world, right? The point is, the combination of these 6 things make AI. Only machine learning does not make AI. It's the combination of these things. And when I'm talking about that semantic Internet of Things, that happens in those 3 boxes there. So I even put machine learning to the far end because everybody wants to talk about machine learning. I was like, nah. So let's look at the new things, right? So and these are the things that people look at less in this context. And the reason I'm not looking at natural language processing is for the simple reason that it's hard. So actually, the friend of mine he works at the university here in St. Petersburg, and his work is as a professor to look at the whole language processing thing. It's insane. It's so difficult. But the other things we can do. So, if somebody says AI in the future, then you go like, okay, AI is not machine learning. AI is these 6 things. And if you forgot what it was, which I recommend you to forget it, and then you just go to my website. and then you can read other articles, tweet about it, and put it on Facebook and stuff, etc.
Okay, no more marketing stuff. Okay, thank you.
More
thank you.
questions.
Okay, any questions more? Thank
So, as I catch correctly, you've mentioned something about augmented reality and how Internet of Things can help us, except of course Google Glass and things like this.
Oh, sorry, the last question I didn't get. So you said how does Google?
How Internet of Things can help us with augmented reality, except of some glasses and stuff like this.
Yeah, so that's a great question, right? So the point that I'm making here is that there are things happening in the physical world, about things that happen in the physical world, and then we go to that in digital. We learn stuff about the physical world. So, and that is now the question is, so what can you imagine about that, right? So, for example, if you are somewhere on Earth and you look at Google Maps where you are, then the GPS coordinates are sent to the Google server and it places the blue dot where you are, right? You here are the thing, and that information that's being processed in the digital world says something about you, where you are in the world, and that you maybe like to travel or that you like to go somewhere. So what you need to do is that you need to try to not look at things in IoT as something with what I would advise as with a chip in it. There's no reason why this bottle cannot be an IoT thing and the water in here cannot be an IoT thing. The question is, how do we use those tools to capture the information? Example, did you remember that picture that I showed you with those people where you saw those squares around? So let's say that you would take a picture of me right now and you would run it to this service. Then you would see that the X and Y axis of the square of the bottle are intertwined with my X and Y axis of the box that's around me, right? So what does it tell you? I'm holding a bottle.
Just recognition.
That's another great question. So if you do this on a large scale, you can ask questions about this. Seriously, what's he holding? A bottle of water. What's he doing? He's standing up. He's giving a talk. And then you go like, so who wants to know that you're holding a bottle of water? Well, I don't know, but just imagine if you would do that with all cars that are driving right now through Russia. And you would know all the context of what they're doing in the physical world. I guess there's somebody interested in that.
Thank you. We have more questions.
Thank you, Bob, for your speech. It's quite interesting.
Thank you.
My question is not about the topic.
In that case, then. No.
Can you tell a couple words about company where you're from? Kubrickology.
Yes.
Yep. And is it related to IoT?
Yes. So that's my company, and there's like this shitty situation because based of this idea, I just got funded to really build this on a big scale. The problem is that's still a secret. So I can tell, I had to send an NDA for my own idea, so I can't tell you anything about it. But soon you will see something about this which is really big. So I'm sorry that I can't tell it, but I signed something so I can say it. But that's my company and that's what we're working on.
Thank you. More questions? Oh, so long way. Okay, the question is to make a flying car, we need a lot of engineering stuff, and no engineering stuff in your slides, as we can see, or at least it was a question. And
so what's not in the slides?
Main engineering stuff to actually make this flying car.
And then the question is? Because that more sounds like a statement, like we need more engineering. Yes, that's correct. Yeah, I agree.
Yeah.
Yeah, but I also think that we need much more, and this is on a serious note, I think we need much more different people. That is why it's so important to have in the whole technology domain to be inclusive, right? We need to have people, creative people, designers, all kinds of different people who think about these things. Because it's not only engineering. Sorry, engineers. It's not only engineering. It's like it has to do with how we live in the world. So we need different people to think about that. Not only, shall I say this? Not only male engineers.
We have to be wizards.
Sorry?
We have to be wizards.
You have to be a wizard, and everybody can be a wizard.
We will try.
Yes? Thank you.
More questions? No? Yeah? Yeah.
Hi. Do you know any examples of semantic Internet of Things in real world already implemented?
Yes.
What?
Yeah, so I was actually inspired. Because I'm freelancing through my company, and I was working for a company which is called Elsevier, and if you studied science or if you're a professor, you probably don't really like that company because they ask a lot of money for scientific articles. But what they're doing, and that is amazing, they do drug discovery based on web semantics through those articles. That is, I've seen it. They're not there yet, but it's amazing. So there's like this saying that you go like, so if people come up with new ideas, they do that by reading stuff, right? So they read stuff and they go like, I have a new idea. And they argue, well, if we use semantics to explain and have the machines read it, they can also come up with those ideas. And now maybe machines are dumber than we are, but they're much faster. So, I challenge you to manually do such a such a model that takes you like 1 million years or something. So machines do that very well. So scientific discovery is big in this. And I also know that there was a Russian company, of which I forgot the name, that tried to be really big on ontology, but that failed. And I forgot the name of the company. But it's like, I think they're like based in Moscow. So some people say like, web semantics is a utopia. It's too difficult. We can do it, but let's go for utopia, right? So let's build something awesome.
Thank you. Test. Okay. If you have no more questions, thank you, Bob.
Thank you.